Hello friends, welcome to Mu Lessons. Today we will learn about DC machines. DC machines includes DC motor and DC generator. As a basic course, we will first come up with your DC motor. So first of all, what is DC machine? We will learn about some of the equivalent circuit diagrams of the motor, the basics of DC machines, and the principles behind the movement of the working of DC motor. So first of all, we'll start with the construction part. Those who have electrical machines in their future studies, they will know it better. So for the time being, we will talk about DC machine construction. It's not very complicated, just simple things. Here we have north pole, south pole. These are the windings around the poles. The main part is the stator and another part is the rotor. Stator part is named stator as it remains stationary, and the rotor part moves continuously, so it is named as rotor. Around this magnet we have the pole shoes, main pole core. The yoke holds the whole DC machine. We have two axes, that is a D axis and the Q axis. Commutator is also required to collect the current from these machines. Here we have compensating winding, shunt field winding. So you will learn about this in your further studies. This is just a brief idea about the DC machine construction. Here I want to add some more points. The stator of the DC motor has poles, as we have seen. This is a stator. As it remains stationary, it has two poles, north pole and south pole. The main pole core, which are excited by DC current. These poles are excited by the DC current through that windings to produce magnetic fields. In the neutral zone, in the middle part, the commutating poles are the place to reduce the sparking of the commutator. Compensating winding are used, mounted on the main poles. These short circuit windings damp rotor oscillations. The main advantage of compensating winding is to damp the oscillation of the rotor. The poles are mounted on the iron core that provides a closed magnetic circuit. The motor housing supports the iron core. It has brushes and bearings for the easy movement and collecting the current. The rotor is a ring-shaped laminated core. Coils have several turns. More the number of turns, more is the EMF induced. The coils are connected in series through the commutator segments. The end of each coil are connected to the commutator segments. Two brushes are pressed to the commutator to permit the flow of current through them. The brushes are placed in a neutral zone where the magnetic field is close to zero, and this reduces the arcing. This is the basic construction about DC machine. Now we will come an application of DC machine. It can be used as a motor or a generator. First of all, we will start with DC motor. What is a motor? It's a device which converts the electrical energy into mechanical energy. Like we have seen the fans, the table fans. What happens in those cases? We give electrical energy and there is a movement of the blades of the fan. It is a kind of motor. The DC motor is governed by Fleming's left-hand rule. Here you need to note 2 points. Force due to the magnetic field, how the force due to magnetic field influences this, and the Fleming's left-hand rule. Now what is the Fleming's left-hand rule? It is the rule that governs the movement of the DC motor. This rule gives the direction when a current flows in a circuit and it is kept in a magnetic field. It is possible to predict the direction of the force acting on a wire if the direction of the current of the magnetic field are known. So if you know the direction of the current and the magnetic field, then you can get the direction of its motion. Likewise, you can see this picture. The first finger, that is the index finger, gives the direction to the magnetic field. Second finger, that is the middle finger, gives the direction of the current. Third finger, that is the thumb finger, gives the direction of the motion. So if we keep our hands notifying the three directions will get the direction of this motion easily. This is a pictorial view of DC motor. In case of DC motor, the force experienced by the loop is given by BIL. You can see we have two poles. Here is a battery. The magnetic field comes from north pole and ends at south pole. So the direction for magnetic field is from north to south. As in the Fleming's rule, the first finger gives the magnetic field. We have to remember these things. Now, in this case, the direction of current is in upward direction. So, by knowing these two things, we can know the direction of motion. Like, the magnetic field goes from north to south and the current goes into the paper. That is like this. So, the thumb goes downwards, and hence the second picture shows the force is experienced in downward direction and the rotor moves. That is, the rectangular loop moves. We will learn it in brief in the next we have an animation video. Now, how can we change the direction of these forces? The forces experienced by the rectangular loop. How? It depends upon two things. The direction acting on the wire is an electromagnetic field. It can be reversed in two ways, that is, either reversing the current. If we reverse the current, that is, if we reverse the direction of current and we apply the Fleming's left hand rule, we will get the motion in a different direction. Similarly, if we reverse the magnetic field also, we will get the motion in a different direction. The direction of force is therefore relative to both the direction of magnetic field and current. In this case, the magnetic field is from north pole to south pole and the current is entering from this side. So you can notice this like this, and the current moves inside the paper. So in this case it is downward direction. You can apply Fleming's left hand rule. In this case it is downward direction. Similarly, in this case also, the magnetic field moves from north pole to south pole and the current is reversed. So in this case also, if you apply the Fleming's left hand rule, it comes up to be the downward direction. Hence the direction of the force is relative to both the direction of magnetic field and direction of current. Now, how do we increase the motor strength? There are some points. We can increase it by increasing the current flow through the coil. The strength of the motor depends upon the force with which the rectangular loop moves. The force is given as B into I into L. So if we increase the current, it is directly proportional to force, and hence the motor will move in a more speed way and the strength will increase. By increasing the strength of the magnet, as force is directly proportional to B, it also increases the strength of the motor. By increasing the number of turns, if the number of turns increases, then also the strength of the electric motor increases. Now we have a video, animation video, you can see it.
Here's the animation video of a DC motor. I have covered from net. As you've already known, this motor follows the law of Fleming's left hand rule. In case of Fleming's left hand rule, we have the magnetic field from north pole to south pole. The current direction, that is the battery is connected to the commutator, is going into the paper, as you can see it. Hence the force will move upwards. By applying the Fleming's left hand rule, the magnetic field is from the north pole, north to south direction. The current is inside the paper and the force will be given by upward direction. This is the Fleming's left hand rule. So this video acts like this. As you can see, as the current moves through the commutator into the coil catches the magnetic field, that is a north to south pole magnetic field, and it experiences a force, and the force is given by F equals to BIL, and hence the Fleming's left hand rule gives the direction of the motion. Again, I can play the video. This is a very simple concept of the operation of a DC motor. Here is using the commutator with carbon brushes to collect the current. The movement of this loop gives the idea of DC motor.
So the animated video have given you a brief idea or a very nice idea about the movement of DC motor. Now we have one thing, DC motor equivalent circuit. In the higher classes, in the 5th sem, you may be reading about this DC motor equivalent circuit. So how do we make it? You will read on those classes. This is just a basic diagram of DC motor. We have two parts, stator and rotor. We are just signifying those parts in this case, the stator part and the rotor part both at a time. So this makes the DC equivalent circuit. The equivalent circuit is similar to the generator, only the current direction are different. Now in case of this equivalent circuit, we have the operational equations like the voltage VDC or the EMF induced is equals to the voltage given EM plus the net current, net voltage across the resistors, that is I into RA, plus voltage drop across the brushes, that is VB, V brush. The induced voltage and the motor speed versus the angular frequency is given by this EMF is given as KIF into omega. K is a constant, IF is the field current with the angular velocity, and this angular velocity can be known as 2 pi nm. Here we have some more formulas regarding this. Km IF omega equals to EAM, and that is equals to VDC minus IM RM. The current is calculated in this equation. The output power is given as, we know power equals to V into I. So net power output is VAM into IAM. The torque is given as power by angular frequency, which is equals to Km Im into IF. There are certain derivations, very small derivations regarding this, you can see from the books. But the main concept around the motion working or the principle of DC motor is the Fleming's left hand rule, Faraday's rule. These two rules, these two laws mostly govern the DC motor operation. In the higher classes, you will read in detail about the pole, the stator equations, the rotor equations, the induced EMF, and many things. Now we have many items in our daily life where we can use this electric motor. Some are shown like this. This electric motor is a device, as said before. It converts the electrical energy into mechanical energy to produce a turning effect. Like in fans, ceiling fans, most motors are powered using direct motor, that is the DC current, which is produced by cells and batteries. Motors powered by main electricity are called alternating current. You will know in the further semesters about alternate AC motors. These motors use electromagnets rather than permanent magnets. In case of DC magnet, we use permanent magnets, but in case of AC motors, we use electromagnets. So these are the basic ideas about DC motor, how the DC motor works, how the rectangular loop experiences a force in the magnetic field, and how the direction of the motion is given by the Fleming's left hand rule. Now if we just reverse it, if we use the if we just reverse the direction of current, then we have seen there will be a direction of motion. Similarly, this motor can also be used as generator, and we will know about this in our next video. Thank you.